and what they want to do with the rest of their life, although they're very young at this point. We also hope that when you pick your girls up after the symposium is completed, that they will be going home understanding that girls can do engineering, that math is not always hard, and that computers are not necessarily a field that belongs only to boys. The final goal that we have would be that your daughters have fun, that they have an opportunity to interact with some of the best professionals in Honolulu, and that they enjoy themselves and perhaps meet a few new friends. Our keynote speaker this morning, wait just a second, I'm going to raise this just a bit. If I can. Our keynote speaker is Dr. Laura Blecha, an Einstein postdoctoral fellow at the University of Maryland. She is especially interested in how galaxies are formed and evolve. She also aims at developing an understanding of the nature of the gigantic black holes found in the core of these galaxies. Dr. Blecha has her bachelor's degree from Northwestern University, a master's degree in astronomy from Cambridge University in England, and her doctorate in astronomy and astrophysics from Harvard University. Girls, what a role model you have this morning. Let's give her a hand just for that. An accomplishment in education and succeeding in some of the world's best universities. But interesting, she was not born in New York City. She was not born in Los Angeles, nor Honolulu. She was born in Manhattan, Kansas. Dr. Blecha's interest in outer space was piqued at a very early age. She says she read everything she could, perhaps even younger than the girls here today, everything about space, and spent countless nights stargazing in the dark skies over her home state. So it is really a pleasure to welcome Dr. Blecha to Sacred Hearts and to this is our 20th Science Symposium for girls. So it's a little special this morning. Dr. Blecha.
Thank you very much for that wonderful introduction. And thank you very much for having me. I'm so excited to be here. I'm going to try to switch this off. Okay, it's off. Thank you. All right, we're good now. Right, so I'm very excited to be here today and talk to you all about being an astronomer. So, as Betty very nicely introduced, I am an astronomer. That's what I do, and I'm going to tell you a little bit about what that means, what an astronomer does, and more of the details of how I went from being someone about your age who was interested in science to doing astronomy for a living. So what is an astronomer? Basically, an astronomer is someone who studies the universe beyond the Earth. And one of the reasons I think that's so cool is because of just how vast and how beautiful the universe is. We have our solar system and all the planets in our solar system. But beyond that, we also can see all kinds of beautiful, beautiful structures beyond in the nearby stars, clouds of gas and dust. These are the places where new baby stars are forming all the time. The massive stars at the end of their life explode and spew gas back out into space, shaping these beautiful clouds and providing more fuel for the next generation of stars to form. We can zoom out then, even from the local stars around our galaxy. This isn't our galaxy, this is a different galaxy. We can zoom out from our local stars and see that we're just one little bitty star on the outer spiral arm of a giant galaxy of stars and gas, actually hundreds of billions of stars. Really giant structures. So how do we know all of this? How do we observe the universe and learn about it? Well, it used to be that this is what an astronomer looked like. Someone who went to an observatory at night in the cold and sat and looked through an eyepiece. And that was the state of things for a very long time. And there's still lots of telescopes like this. They're usually mostly used for just educating the public, letting people learn about the universe, rather than for science. Today, we use state-of-the-art telescopes that are much bigger, like this one on top of Mauna Kea, very nearby, to learn about the universe, and we can get much better images. And instead of looking through an eyepiece, we get the data sent to a computer and look at it in a control room, something like this. And actually, most of the images I just showed you were from the Hubble Space Telescope, which orbits the Earth. Most of you have probably heard of it at some point or other. And what it does is it allows us to eliminate the blurring effects of the atmosphere completely. It's even better than being on top of a mountain. As tall as Mauna Kea is, this is one step better to eliminate the atmosphere entirely and allow us to get those exquisite pictures that I showed you before. So there are lots of different kinds of astronomers. Some are mostly observers who go, to telescopes and take these observations and try to analyze the data and understand what it means. And then there are people like me who focus more on the theoretical side of things. And in specific, I do a lot of computer simulations, trying to understand the physics behind how the things we see in the universe came to be. So this is my office at the University of Maryland, a very candid photo here of me. And this is where most of my astronomy happens, in front of a computer screen. But the simulations I run are very big. Since galaxies are so complicated, we need much more powerful computers than just a simple desktop. So the simulations are actually run on huge supercomputers like this one in Texas. This supercomputing facility is one of the most powerful in the world, and I think its power is something equivalent to about 10 million laptops put together. So we need very powerful computers to understand things about the universe, but we can make some pretty cool simulations and learn quite a bit. So I would like to go into a little more detail now and tell you exactly what it is I do study with these simulations. The first thing being colliding galaxies, huge train wrecks, two galaxies actually smashing into each other, which happens more often than you might think. It turns out that our Milky Way galaxy is just one fairly average galaxy in a huge universe. So this is a picture of the Hubble Deep Field that was taken by just pointing Hubble Space Telescope at a very dark region of the sky for a long time. And what they found is that, okay, there's some close by that you can see are actually galaxies, but every single little pinprick of light here is another galaxy that's so distant that all we see is that little point of light. So it turns out there's something like 100 billion galaxies in the entire universe, at least. And what inevitably happens is that sometimes they crash into each other. Every once in a while, more often than you might think. And when that happens, we get these crazy structures, these galaxies that don't look like normal galaxies at all, because they're being hugely distorted by the gravity of the other galaxy, tugging and pulling it, creating these big tails of stars and gas flinging out into intergalactic space. And so the technical term we like to use for these is train wrecks. That's pretty much what they look like. And when two big galaxies like this smash together, you really just get a huge mess for a while. And then eventually it'll settle down and just form one big galaxy. So this is an example of a computer simulation of galaxies merging. And what it's going to do is it's going to pause and then show you how we can match this to real Hubble Space Telescope images of galaxies merging. And this gives you kind of an idea of how we can use simulations and observations together to understand how these mergers actually happen. So you'll see the galaxies, as they start to merge, they're going to get increasingly distorted. They're starting to strongly interact. Then they're going to start flinging stars and gas off into space, strongly disturbing structures. You can see all the gas and dust lanes here. And you can see how there's such a rich diversity of the real galaxy mergers that we actually observe. And eventually, as the galaxies evolve far enough, they will settle down and, as I said, form one giant merger remnant. The other thing that I study is monster black holes. They are sitting quietly some of the time in the centers of galaxies, sometimes not so quietly. This obviously is an artist's conception of what a monster black hole looks like. And when I say monster, I'm talking about something that weighs millions to billions of times more than the sun. The sun is already pretty big compared to the Earth. So these are really, really giant things sitting at the centers of galaxies. But before I talk about those, I need to take a step back and talk a little bit about what a black hole is. Okay? And to do that, I'm going to start by talking about a person standing on the surface of the Earth, just like we all are. Okay? Now, if that person jumps, they fall back down. I don't think any of you were surprised by that outcome. And in fact, I would have to jump quite a bit faster to actually escape the Earth's gravity and keep going off into space. The space shuttle can do this. It has to achieve a velocity greater than the escape speed from the Earth's surface, which is about 11.2 kilometers per second to escape and get out into space. Now, a kilometer is a little less than a mile. So you think about going 11.2 kilometers every second. That's a really fast velocity to get away from the Earth's surface. But it turns out that that's peanuts compared to a black hole. So a black hole, so there's not really a surface to stand on in a black hole, but there's sort of this invisible barrier here. It's a point of no return. Once you cross that invisible barrier, you're not going back at all. And the reason for that is that the gravity inside of here is so strong that if you shine a beam of light, even light would not escape. So the light, just like me jumping up and falling back down, the light would do the same thing. And it's trapped forever in the black hole. And that's the same as saying that the escape speed from this horizon here, from this invisible barrier, is the speed of light. For those who are counting, that's 30,000 kilometers per second. An unimaginably fast speed. Okay, so these black holes are objects whose gravity is so strong that not even light can escape from its surface. So if no light can ever get out of them, how do we know that they exist? They are, by definition, the darkest objects in the universe. Well, it turns out that if we zoom in on the center of our galaxy, this first part is just sort of a conceptualization of what zooming in here. But these orbits here are real data. The astronomers have been tracking the orbits of stars in the center of the galaxy for about 20 years, and very carefully seeing how they move around this dark, unseen object in the center. And they know that it must be really big because it's holding these stars in their orbits that are going really, really fast. And so they know that there's something really compact and really heavy there. And we know that it has to be a black hole. There's nothing else that it could be if it's that big and that small, or that massive and that small. So that's one way that we know that there's a black hole that has 4 million times the mass of the sun in the center of our galaxy. Now, actually, sorry, I'm going to, there we go, make one more point here, which is that it's a very common misconception that black holes are these giant vacuum cleaners that just suck everything in. That, like, maybe eventually they're going to suck the entire galaxy into themselves. And that's not actually true, because these stars, as you can see here, are happily orbiting around, just like they were orbiting around any other object of that mass. And As long as they stay far away enough from the black hole, that's the way it's going to be forever. They can orbit around happily. They won't feel anything unusual if they're far enough away. And it's the same if you're an imaginary space traveler far enough away from the black hole. You'll just orbit around forever, happily. Nothing goes wrong. But if you do start to get too close to the black hole, then crazy things start to happen, and it gets a little bit less pleasant to be our intrepid space traveler. What happens is the gravity on your feet is stronger than the gravity on your head, and so you feel tidal forces, the same as the moon tugging on the Earth, creating tides in the ocean because it's tugging on one side more than the other. So what happens is you get stretched out and ultimately ripped apart. These black holes can even rip apart entire stars. So this is very powerful force here, these tidal forces. So you definitely don't want to get too close to the black hole. But again, this is something that only happens when you're really close. Now the cool thing is, right at this very moment, there is a giant blob of gas that astronomers have discovered that's falling straight towards that black hole in the center of our galaxy. This is a simulation of what we think will happen. It'll get ripped apart completely. Not all of the gas will fall into the black hole. Some of it gets flung off into space, shining brightly so we can observe it. And then some of it will actually fall back onto the black hole and will eventually be eaten by it. And we can get an unprecedented look at how the black hole eats gas. We've never seen anything like this before, so close up that we can see it in this detail. So that shows you how these tidal forces really do work the way that we think they do. So we do learn some things every once in a while. So this also leads to a point about another way that we can observe black holes, even though they're black holes and they don't emit light. And that is that when there's a lot of gas falling onto a black hole, it's going to orbit around and around and around. It has to lose a lot of energy to spiral in all the way to get eaten by the black hole. And when that happens, all this gas is spiraling around and around and creating all this friction by rubbing against other gas. And that heats it up incredibly hot and makes it glow really brightly. So brightly, in fact, that some of these around the giant black holes can glow as bright as an entire galaxy all by themselves. So these can be very, very bright objects, even though their core, the source of their energy, is this black hole that can't have any light at all. So the forces of these black holes when they start eating gas are so powerful that it can transform a galaxy that looks sort of like this average galaxy edge-on spiral that you're seeing here into something that looks like that, spewing huge jets of matter and light out to distances far beyond the size of the galaxy. This is just one of the more nearby spectacular examples, but we see this kind of thing all the time. These are extremely powerful engines, these monster black holes. So I'd like to shift focus a little bit now and talk some more about how I ended up being an astronomer. As Mrs. White very nicely said at the beginning, I am, in fact, from Manhattan, Kansas, which is very different than Manhattan, New York. Kansas is right smack dab in the middle of the country. This is our downtown. It's a quiet little college town. And one of the great things about Kansas is we have beautiful landscapes, prairie and fields, and lots of wide open spaces that allow for very dark night skies. So how many of you, raise your hands if you've ever seen the Milky Way in the night sky? Okay, good, quite a few of you. Yeah, those of you who haven't, the next time you get a chance to see it from a relatively dark side away from the city, look for this. It probably won't look this spectacular. I think this is a time-lapse photo, but you can see a milky band going across the sky, and that's you staring along the disk of our Milky Way towards the center of the galaxy. It's pretty cool when you think about it. Anyways, as a kid, I loved stargazing. I was just totally captivated by the dark Kansas skies and being able to see everything, these meteor showers, satellites going by, planets. It was one of my favorite activities. So that's sort of how my interest in astronomy really got its start. I love learning about the constellations. This is a little star map that I drew at some point in my youth. And I also decided I was going to be an astronaut. That was my goal. And I was very lucky that there was actually a space camp just a few hours from where I grew up in Hutchinson, Kansas. There's a few different space camps around the U.S. So here I got to learn how to fly a simulated shuttle mission and do all sorts of cool things, learn about being an astronaut. And so this was what I was very into. At some point, I've got to say, I did realize that I was more interested in the science part of it than learning to fly the space shuttle. But if someone said to me tomorrow, Laura, do you want to go to space? I'd say yes. I was interested in other kinds of science too. I had an opportunity to take this field biology class where we went to Kansas and Colorado and learned about all sorts of plants and wildlife and ecosystems. But I didn't do science all the time. I did lots of other things when I was a kid. So it's not like you have to just study or only think about science and nothing else if you want to be a scientist. You can have a perfectly normal life, do all sorts of different activities. I was actually super into music. When I was a kid, I played the flute and piano, did all sorts of music competitions. I was in band and orchestra. So I did all sorts of things. I was in 4-H, which is sort of like Scouts, but it's sort of a youth organization that originated in rural areas in the U.S., if you haven't heard of it. And so I did things like gardening projects, woodworking projects. So plenty of different other non-science things that I did when I was your age. And then since then, the path that I've taken in order to be where I am today doing astronomy as a career started out at Northwestern University outside Chicago, where I went to college. And that's where I had the opportunity to start doing research for the first time. I had a great advisor who was doing research on black holes, and I thought that was really cool. And so I started working with her, and I haven't looked back. I did an internship between my sophomore and junior years at UCLA in California, giving me more research experience. And then after I graduated, I went to Cambridge University in England, and finally did my PhD at Harvard University in Boston. And then finally I ended up at University of Maryland, where I'm doing my postdoctoral fellowship now, which means that my job is to do research. So I go into work and I study things about the universe. And I think that's pretty cool. It's never boring, I can tell you that for sure. And one of the reasons it's never boring is that we don't always just sit at our desks and do stuff with our computers to do science. It's a very collaborative experience. You have to talk to other scientists and find out what they're working on, and you tell them what you're working on, and maybe they have a good idea you haven't thought of. You work together on projects. You can be more efficient than one person can by themselves. So some astronomers, go on observing runs to telescopes in places like Chile, Australia, and Hawaii. We give lots of talks at conferences and seminars to tell each other what we're doing and the results that we have. And we spend lots of time just interacting, as I said, so we can learn about what each other are doing and form a community that's working together to understand the universe. But all of this happens because it's such a global community. One of the great perks of being an astronomer is I've gotten to travel a lot. To conferences and seminars all over the world, and I personally love to travel. So to me, this is a huge perk of getting to be an astronomer, and not only meeting people from all over the world, but seeing places that I wouldn't have otherwise gotten to see. So, sort of just to conclude here, I would like to talk a little bit about, more generally, why it's fun to study science or technology, engineering or math, any of those sort of technological fields. Because I've talked a lot about being an astronomer, but there's such a huge, diverse range of things that you can do if you study one of these areas that's just sort of the tiniest tip of the iceberg. So whether you want to discover life-saving drugs, or new ocean life, or develop bridges, or develop new apps for your smartphone, science and math and technology is never boring. It's fun, it's challenging. I'm not going to lie, my job is definitely challenging. I work hard, and I have to be very dedicated to make progress. But really, when I take a step back and realize that I'm learning things that no one in humanity has ever learned before, I'm pushing forward the forefront of human knowledge, that to me is so cool that, it makes it all worthwhile, even when it's hard. From a more practical standpoint, it turns out that jobs in science and technology are growing something like 5 times faster than all other jobs. And this is predicted to only continue over the next 5 or 10 years at least. So, it's a great opportunity for finding a career in any sort of field that uses these skills. And finally, we carry around computers in our pockets every day. We have them in our cars. Technology is everywhere. And so even if you're not going to be a scientist, certainly if you're not going to be an astronomer, most people aren't, there's not very many of us. So even if you're not going to be literally reaching for the stars, quote unquote, if you study science or math or computers or engineering in school, it's going to open doors for you, and that's the bottom line. So I'll stop there and take any questions. Thank you. I think we have a couple of mics there.
What are you going to do after this job?
That's a great question. So right now I'm a postdoctoral fellow, which means I have funding for a certain number of years. And so my ultimate job is to try to be a professor at a university. And so I will both do research and teach college classes. So in the next few years I'll be applying for those jobs. Anyone else have any questions? Don't be shy. I went over a lot of science stuff, so you can just say that part didn't make any sense. If you want to. All right. There's no more questions? No? Okay, good. Do you have a question? Yeah, go for it. Right here.
What happens to the living in when the galaxies collide? Do they just die?
That's a good question too. It's a very good question, and it's very relevant because our Milky Way is currently on a collision course with the next nearest big galaxy called the Andromeda Galaxy. So in a few billion years, we're going to find out firsthand. I don't think anyone in this room is going to be around to find out firsthand, but it's true. So it turns out that there's so much space, is so big, that there's so much empty space between the stars that when 2 galaxies crash into each other, lots of crazy things might happen in their centers where there's lots of gas, but the stars would just pass right through each other. So our solar system could get flung off into intergalactic space, but all the stars would go along with the sun. And so if there was any life on another galaxy when it's merging, probably they would get a very different view in their night sky. Things could look pretty crazy for a while, but they probably wouldn't die. Thanks for the question. Oh, good, we've got a line now.
How long does it take for black holes to form?
Ooh, that's another good question. So it depends on what kind of black hole. So the normal black holes, quote unquote, if there is such a thing, form when the most massive stars explode at the end of their lives. And whatever doesn't get flung off into space collapses and becomes a black hole. And so that happens very rapidly, in the course of a day or so. But the monster ones that I talked about, we actually don't know very well how that formed. That's one of the things we're trying to find out right now, but it's hard because it happened so long ago in the early universe. And we think that they formed more rapidly than we can understand easily, which means that they might have taken 1 million to 1 billion years to form. astronomers have very funny ideas about time. So that's practically true.
Do you name monster black holes?
Ooh, that's a good one too. We don't get to name them very fun things like Scruffy or George. The black hole in the center of our galaxy is named Sagittarius A star. And aside from that, you usually just associate them with the galaxy itself. So the galaxy will have some boring name like NGC 6240. I'm not even joking, that's how it works. So we actually call them telephone numbers usually more than we call them names, because there's a string of identifiers.
Have you ever been to a telescope on the Big Island?
I haven't, no. I'm actually going to the Big Island after this to visit some friends who are astronomers, and I'm hoping maybe to go to that.
Has anyone ever been sucked into a black hole?
Not that I know of. That's what I do. No, I talked about a lot of scary stuff here, so it's good to check. No, we're all safe. There's not going to be any black holes in our neighborhood anytime soon. And as far as I know, unless there were some very brave aliens in another galaxy who went exploring, no one's ever been sucked into one.
How do you know if there's a black hole in front of you if you're in a spaceship before it's too late?
Ooh, yeah. Another good question. So probably what would happen is that you would see all of the gas that was falling onto the black hole shining really brightly. But just in case it was a sneaky black hole that didn't have any gas falling onto it, you might have a hard time. And you might not notice anything until you started feeling some funny forces that started messing with your electronics on your spaceship. But the good thing is that black holes are so compact that your chances of running into one are zero.
Girls, I apologize, but I was told that we have to stay on schedule. And I'm delighted that all of you got up and you've got these bursting questions.
Yeah, these are really great questions.
Aren't they though?
I'm very
But we have to stay on schedule. All right?
You can
Thanks,
grab me
though.
later.
Okay, so wait just a second, everybody. We're not ready yet. Jimmy, can we have some lights, maybe? I was a little nervous on stage this morning, not because of the crowd or anything like that, but I think that Dr. Blecha mentioned so much about technology, and if any of you are teachers or in your jobs, you know that technology is just such a wonderful blessing in our lives these days. But if you have a crowd like this, and so much was dependent on her presentation, it was dependent on technology, putting 3 and 4 systems together at times. And when I was standing up there, I was just so scared that I was going to touch something on the computer that would affect the rest of the morning. So I'm just going to stand down here. I want to quickly mention to you that I'm Betty White. I'm the head of school here at Sacred Hearts. And again, it's a pleasure to have you. I want to just give you a little bulleted idea of what the morning is going to be like. At this point, when I'm finished speaking, the girls will exit the auditorium. And they will go and have some light refreshments in the student center. And from that point, they will go to 2 workshops. And parents do not have to worry. There's so many people in these blue shirts that are out there to tell them what to do. So you can relax and they'll be taken very, very good care of. As the girls exit the auditorium, make their way to the student center, we have girls at the back that are going to direct them to the student center. We ask that you take just a moment and regroup yourself as an adult and move up front, because then Dr. Blecha will be talking only to parents. And it's better for her if we're all sort of close together. All right? Guides in the back, you're ready to take the girls. All right? So girls, start making your way toward the back doors. Jimmy, can we have some light to begin with? Good morning again, and thanks for your patience. I want to say a few words before Dr. Blecha talks with us. And I don't really know exactly what she's going to be telling you as parents, but I just want to share with you what I feel and how Sacred Hearts has been responding to the economy and to the condition of society in the past few years. And we, here it's a very special situation because, of course, we're all girls. So we're always focusing on what is good for girls. Now, some of you know, if you keep up in the daily newspapers, that in 2012, 2013, we can take the enrollees at the University of Hawaii, their community colleges, and the main campus in Manoa, and 54% of their enrollees were women. And we breathed such a wonderful sigh of relief that women have come so far in such a short time. But then the next day in the paper, we're confronted with the data that 80% our women, regardless of the job, are usually getting about 80% of the salary of what a man is making. A lot of our women go into fields in which they cannot make very good money. Another thing that I always tell the girls that I work with on a daily basis is that in Hawaii, 30% of our families, 30% of our families are taken care of by a single parent. And I think you know what I'm going to say next. That 30% of our boys and girls are taken care of by a single parent. And of that 30%, 88%, that single parent is a woman. In Hawaii, half of our single mothers, half of single women with children, live in poverty. If we take their income and compare it to normal conditions. I had the sort of like a light bulb go on. It was only yesterday. And of course, you know that this is a private school and parents have to pay tuition. And if any of you have children in private schools or you have associations with private schools, one of my tasks yesterday afternoon was sit down with the business manager and to try to come to some resolution with parents who were delinquent with tuition. It's common. All private schools have it. So I saw a light bulb that I'd never seen before. Because in so much of the talk between the business manager and me, it was that Jane is from a split family. Mom pays 50% and dad pays 50%. Dad's got his paid. But mom is struggling. Mom is challenged to come up with that. And so, you know, I listened to that story 3 or 4 times. I thought, oh my goodness, we know why. Because lots of times the women are making much less money and they're in jobs where money is not as easy to come by. So when I talk with our girls, I always mention to them that they want to be, when they leave high school, they go to college, they decide what their profession is going to be, and that they become financially independent. And I think that's a good theme song for parents. Here in Hawaii, we have over a divorce rate of over 50%. And then sometimes it comes in with some of the data that I shared with you this morning. So we want our young women, if they, after their college is over, their training is over, that we want them to be able to take care of a family if they choose to do it alone, or if they're put in circumstances that they do not have to go back to mom and dad to live with them, but the mother can take care of it. And we think that one of the ways is to steer the girls into what we call the STEM fields. And now we've been talking about STEM fields for, 20, 30 years, but it's not going away. And that's one of Dr. Blecha's strong points today, is that she is in the field of science. So when I talk with the girls, I always mention that if they can become interested in science, technology, engineering, and math, the world is going to be wide open to them as far as getting good jobs. We know that here in Hawaii, we have over 50% of the job market is women. And then it's just amazing that only 20% of our women are in STEM fields. And this is where the job market's going to be in the next 20 years. I'd like to share just real quickly something else that happened about, not more than 10 days ago. We had something here at our school called, it was called a STEM forum. It wasn't for students, and it wasn't for parents necessarily. But we had Dr. Helen Lewis from the Dr. Lewis from the East West Center. We had Dr. Turner from Chaminade University, plus a couple of other people on the panel. And I loved what they had to say to us. First off, when I visited with Dr. Lewis at the East West Center, I sort of acting like a know-it-all, and I said, we try to get these girls to go into STEM fields because it's going to bring on financial security in the future. And I still think her take was a little different. Her take was, sure, financial independence, but the world needs the female perspective. The female perspective that these girls bring to what engineering, astronomy, whatever, is very, very important to the world. Another thing that I left that forum sort of thinking was that the ladies made such a point that in high school, even in junior high, our counselors, our teachers, our administrators must do a better job counseling girls. Because Dr. Turner said, when I look at my freshman biology class, and I do a little poll in the class, it's that they all want to be doctors. And she said, they're not going to all be doctors, but they can certainly all go into STEM fields. So I'm hoping that we're coming from different areas of the map today. Dr. Blecha is from the University of Maryland, and she, of course she knows the big global as well as the national picture. But it's also an issue here for us in Hawaii. So Dr. Blecha, I hope that it's all right if I share these local concerns about our job market and about our women. And hopefully it will just bring it all home in what you share with us. Thank you very much.
Okay. Thank you very much for that introduction. That really, touched a lot of great bases and really set me up well for what I'm going to talk about. So I'm just going to share some of my thoughts on why pursuing STEM fields is important, even if the girls aren't going to necessarily go into science careers or even STEM careers. I would like to convince you today that there is value in encouraging girls to be interested in science and technology, engineering. So the very first thing I'd like to start out, let's see, can we get the lights down a little bit? Thank you. The very first thing I'd like to start out with saying is that I absolutely have to give my parents credit for being my first science mentors. Unwittingly perhaps, but they were certainly nothing but encouraging when I expressed interest in sciences and really tried to encourage me throughout my childhood to pursue that and develop it. And the anecdote that I really like to tell is that when I was pretty young, early elementary school, I remember asking my father why it looked like there was a man in the moon. I said, okay, I know there's not really a man in the moon, so why does it look like a face? And he said, well, because there's mountains on the moon. You know, there's mountains and valleys, and the sun makes shadows when it shines on it. And that was the first time it had occurred to me that the moon wasn't just this disk sitting up in the sky, but it was this three-dimensional sphere that you could walk on if you went there, you know, and it just really put it together in my mind, and I was amazed. And that's my first memory of being really interested by space. And so, you know, my parents really did have the earliest role in making me interested in science and encouraging that. So the takeaways, I would say, from today are that there are many reasons to encourage your child's interest in STEM. This is why I introduced that term. I'm going to be throwing it around a lot. So just to say again, STEM is an acronym for science, technology, engineering, and math, and everything that encompasses, which is a lot. It's very diverse. And the second thing that I want to convince you of is that encouraging girls in these fields is especially critical for a number of reasons. So, to start out with, this is the graph that I showed. The girls' STEM skills are in high demand. Jobs requiring STEM skills are growing about 5 times faster than all other jobs, projected over the next 5 years or so. And that trend is only expected to continue. And so just to take a step back and define what I mean when I talk about a STEM job. It's an incredibly diverse definition. It's any job that requires specialized knowledge in science, technology, engineering, or math. And you know, I really sat down to kind of make a list of these, and it kind of just kept growing and growing over time. And I'm sure I've encapsulated only a tiny fraction of the actual jobs that employ people. So just to give you kind of an example, you know, science jobs can incorporate anything from, you know, biology fields, biochemists, biophysicists, agriculture and food science, materials science, environmental science, geology, physics and astronomers like myself, archaeologists, doctors, nurses, psychologists, physical therapy, pharmacists, dentists, dietitians, meteorologists. All of those fall under science careers. And certainly not all of those, but most of them don't require a PhD. Technology. So there are people who design web pages. That's probably the most visible way we interact with people in technology fields when we use websites or applications. And then computer programmers who actually design software that we use. But because computers have played such an exponentially increasing role in our lives, the diversification of the different specializations in computers that people can go into has just grown over time. Now we have systems analysts, software engineers, database administrators, and data scientists who handle huge data sets. Like Google has huge servers and warehouse-sized buildings that someone needs to figure out what to do with. Research scientists who are at the forefront of new computer technology, systems administrators, information security analysts, and then we have engineers. Now, engineers, I'm not an engineer, and everyone probably has some idea of what an engineer is, but the truth is that pretty much every single thing we use in our daily lives has been engineered in some way. Literally everything from cars to carrots. Engineering even plays an increasing role in agriculture in the modern era. So there's just a vast range of different types of engineers: chemical, civil, architectural engineers, landscape architects, electrical engineers, materials engineers. Those are the ones that design, just the everyday objects that we use, microphones, skis, and chairs, and everything. Aerospace engineers, petroleum engineers, nuclear engineers, work on energy problems. Agricultural engineers, as I mentioned, there's a lot of increasing technology in agriculture. Environmental engineers, and then math. So math is something that you use for all of these professions to some degree, and obviously something you learn in school is a foundation for going into a STEM field. But aside from being a mathematician who is at a university and just comes up with different theorems, of these obscure pieces of mathematical theory, there are some very practical applications of more pure math as well. So statisticians, we use statistics for all sorts of analysis of the data in daily lives. Actual mathematicians, actuaries, economists is a big one. Financial analysts, market research analysts, all sorts of people that analyze the data that big companies need to figure out their future strategies and so forth. So that's just sort of a tip of the iceberg sort of look at the diversity of different jobs that make up STEM careers as a whole umbrella term. But since I am myself in academia and pursuing an academic career, I want to highlight a little bit about that in particular, with the caveat, or the important note, that this is actually a small, very small fraction of all STEM jobs. So something to keep in mind. So basically the path of a typical academic career starts with a bachelor's degree, where you major in a relevant field. For example, I majored in physics with a concentration in astronomy when I was an undergrad. Very crucial point here, again, most non-academic STEM jobs, like I said, these are only a small fraction, most non-academic STEM jobs require only a bachelor's degree, no training beyond that. And here's just a little graph demonstrating that. So maybe a quarter of STEM jobs by this estimate here in this study require some training beyond a bachelor's degree, and all the rest require a bachelor's degree or less. So again, we're talking about these academic careers as only a fraction of the total STEM jobs. If you go on to a graduate degree, a master's or a doctorate, a very important point to note is that grad school in the sciences, not in the humanities usually, but in the sciences, is typically tuition free. So I have $0 of debt from grad school. In fact, they paid me a stipend for living expenses. So it was basically like having a job when I was in grad school all those years. I wasn't making a lot of money, but I wasn't taking out loans to stay in school for an extra many years either. And so that's a huge, huge advantage. If you do decide to pursue grad school, that this is something that's feasible financially, regardless of your circumstances. The other important thing to note is that STEM training really gives you a lot of transferable skills. Skills that can be applied to things outside of academia. So, by pursuing a quantitative field, you gain problem-solving skills, critical thinking, quantitative analysis, and technical ability with coding or something like that. So, I have friends who have left grad school or finished grad school and then left academia and gone on to work at all of these companies. As software developers, as consultants, as analysts, there's just a huge range of jobs that are looking for people with quantitative and problem-solving skills. And so, even if you start out on this academic track, there's always options for pursuing something outside of academia. So then we get to after grad school. This is where I'm at right now. I'm a postdoctoral researcher. That's a term appointment. It's not a permanent position. Some people, it's a little more rare, at least in my field, get a lecturer appointment to just teach college classes. And then ultimately that might lead to a permanent position or a tenured position as a college professor, either teaching alone or teaching and doing research. And then there's also jobs, especially, there's some in physics and astronomy, but especially outside of more biological sciences. There are lots of jobs for research scientists, both in the industry and at federal institutions like NASA and national labs like JPL and Lawrence, Los Alamos and so forth. So that's sort of an overview, just to give you an idea of what it means to be a scientist in academia and what sort of options are available. The other important thing, just from a structural standpoint, teaching salaries are usually paid by universities, but most of the research funding comes from government grants. So my fellowship is paid by NASA, for example, and the professors that I work with, even though their salary comes from the university, all their funding to hire postdocs and grad students and do research and buy computers and stuff comes from government grants. So that's just sort of a side note, also sort of a plug for the next time you have an opportunity to influence your congresspeople about funding for science. Keep in mind that it's very important to all of our livelihoods and our ability to keep doing new science. So, as I said, these STEM jobs of all kinds, academic and non-academic, are in high demand. And here's just another graph showing that. Even during the recent recessions that we've had, shown here in gray, this plot of year, in the last 20 years or so, the unemployment rate, obviously went up during the recessions, but it went up a lot more and remained higher overall for people in non-STEM jobs. So the unemployment rate, even during recessions, is lower for people who have STEM training. And here in Hawaii, this also holds true. For STEM fields, there are something like 2.5 jobs for every one person seeking a job. And for non-STEM, the ratio goes the other way. There's something like 3 people looking for a job for every one position to be filled. And so that's a pretty powerful statistic right there, I think. Now, the other important thing to keep in mind is that most of these jobs will be in computing. I talked to the girls a little bit about how computers really affect everything we do. And not everybody has to be a computer programmer, but I think it's increasingly important that we think of computers as the language in which things are accomplished in the way that our world works. So this graph is showing that something like 71% of new jobs in the next 5 years or so will be in computing, and then the breakdown of exactly where those will be. But the problem is, at least from the standpoint of the U.S. economy and people who are looking for jobs, is that again, this is showing a slightly different statistic, saying that about 60% of computing jobs will be in, or 60% of new jobs will be in computing, but only 2% of college students are computer science students. So there is predicted to be a huge shortfall of students who are trained to fill these jobs in the U.S. And I was reading some studies, trying to pin down these numbers while I was putting together this talk. And a lot of the studies I was finding that were looking at this from a market analysis point were saying, oh, well, we have to solve this problem. So clearly we're going to have to look at non-U.S. markets and go to China and stuff and start figuring out how to globalize these jobs. So that's sort of from the company standpoint where they're looking. And from the standpoint of people here in the U.S. who are thinking about, possible future careers down the road, certainly it's a great opportunity for anyone who is interested in going into these fields to, keep some of those jobs in the U.S. So one of the reasons that these numbers are so low is that, students, computer science is one of those things that you don't really traditionally interact with until you get to college, if at all, right? So, we all take math. So a lot of us take science. But computers, something like 9 out of 10 schools don't have any programming classes at all. I'm not sure whether my high school, I think maybe they did have a computing class, but if so, it was like, not really advertised. I didn't know anything about it. I'm pretty sure it was all boys. It never was made to sound like something that appealed to me at all. And I didn't really know anything about it. And in hindsight, now that I'm using computers and programming skills every single day that I'm at work, I really wish that I'd gotten an earlier start, but I just didn't realize that it was an option or something that I might find interesting. Well, it's true at the national level, something like 33 out of 50 states, even if there are computer science classes, they don't count towards graduation requirements. This is a nice quote, I thought, from Steve Jobs, to sort of put it in the mindset of why learning to program is such an important part of our future. And there's a video, this will take a little time, but I think we have some time. And I just would like to show it.
Freshman year, first semester, intro to computer science.
I wrote a program to play tic-tac-toe.
I think it was pretty humble beginnings. I think the first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had somebody come up and say, hello world, and I made a computer do that. It was just astonishing.
Learning a program didn't start off as wanting to learn all of computer science or trying to master this discipline or anything like that. It just started off because I wanted to do this one simple thing. I wanted to make something that was fun for myself and my sisters. And I wrote this little program and then basically just add a little bit to it. And then when I needed to learn something new, I looked it up, either in a book or on the internet, and then added a little bit to it.
It's really not unlike kind of playing an instrument or something, or playing sport. It starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned, and I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than sort of coming up with complicated algorithms as people traditionally think about it.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
You should probably know your multiplication tables.
Genius to read.
Even if you want to become a race car driver or play baseball, or build a house, all of these things have been turned upside down by software.
What it is computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Here we are, 2013. We all depend on technology to communicate, to bank, information, and none of us know how to read and write code.
when I was in school, I was in this after-school group called the Whiz Kids, and when people found out, they laughed at me, and all these things. And I'm like, man, I don't care. I think it's cool, and I'm learning a lot, and some of my friends have jobs.
Our policy is literally to hire as many talented engineers as we can find. The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
To get the very best people, we try to make the office as awesome as possible.
We have a fantastic chef,
Free food,
breakfast, lunch, and dinner.
free laundry.
Snacks. Even places to play and video games and scooters. There's all these kind of interesting things around the office, places where people can play or relax, or go to think, or play music, or be creative.
Whether you're trying to make a lot of money or whether you just want to change the world, computer programming is an incredibly empowering skill to learn.
I think if someone had told me that software is really about humanity, that it's really about helping people by using computer technology, it would have changed my outlook a lot earlier.
To be able to actually come up with an idea and then see it in your hands and then be able to press a button and have it be in millions of people's hands, I think we're the first generation in the world that's really ever had that kind of experience.
Just to think that when you can start something in your college dorm room and you can have a set of people who haven't built a big company before come together and build something that 1 billion people use as part of their daily lives is just crazy to think about, right? It's humbling and it's amazing.
The programmers of tomorrow are the wizards of the future. You're going to look like you have magic powers compared to everybody else.
I think it's amazing. I think it's the closest thing we have to a superpower.
Great coders are today's rock stars. That's it.
All right. So yeah, that was kind of a fun little video. It said a lot of things that very well from straight from the source of Mark Zuckerberg et al. So just to sort of continue from that. Sorry. One more statistic to throw at you is that on average people with training in STEM fields earn higher salaries, but the critical point that I wanted to make here is this is true on average even if they aren't working in a STEM job. Okay, so people who have training, in some sort of technical skill, even if they take that and go work in the entertainment industry or something else, they, outside of the STEM field, they will, on average, be in positions that have higher salaries than people with no STEM training at all. So, even if your child doesn't want to go, be a scientist or computer programmer, this is, still something that could be valuable for them to pursue and gain skills in. And in addition, as I said before, there are a lot of transferable skills that you gain by learning science, technology, engineering, or math skills. Critical thinking and logical reasoning, valuable, as I said, for many jobs, but also just sort of, I feel like as being a citizen of humanity. Everybody gets, a bunch of those studies have shown things coming up in their news feeds all the time, telling us which foods we're supposed to eat and not supposed to eat, or what's going to happen, how bad the winter's going to be next year, things like this. And I feel like the ability to critically analyze and say, actually that doesn't really make sense, or oh yeah, I think this is something I want to learn more about, and looking where do these people get their information? How did they do this study? Let me take a little bit of a closer look at where this claim is coming from. And I think those are valuable skills for everyone to have and to develop. And I feel like that's something that you get when you study these quantitative fields. It's a different way of thinking in a logical fashion and thinking critically about problems that are just valuable in general. And also just the point that there will be fewer and fewer jobs outside of STEM that don't require some kind of technical skills. One anecdote that I think is pretty cool is a high school classmate of mine who was in, a lot of she was very bright. She was in all of the, advanced math classes and whatnot with me. And she, today she's an artist. She's a professional artist. And she makes clay figurines that she sells on Etsy. So she maintains this Etsy webpage, and has to deal with all of the customers and buyers and shipping orders and everything. And then she also has this incredibly detailed knowledge of all these different glazes and how to heat her clay creations in the kiln, the right temperatures, and what different chemical reactions are going to come out of it. And I just think that's a perfect example of someone who, has taken, is applying science and technology to being an artist. Something like, who would have thought? But in today's world, if she wants to sell her stuff online, and just the nature of her work, she needs those skills. So, let's see. I have a little bit more time before I'm halfway point, right? 2. Is that okay? I couldn't quite remember when we started. So I want to talk about why. The second point I started out saying, why is it so critical that we encourage girls, especially in STEM? And there are several reasons. The first being that, as Mrs. White said, women earn a majority of all bachelor's degrees on average. We've achieved equality and then some in college degrees, which is awesome. But it turns out that men are almost twice as likely to declare a STEM major. And if you look only at engineering majors, they're 5 times as likely to declare an engineering major as a woman. And they're more than 7 times as likely to declare a computer science major. So there's huge deficits of women that are even going into these areas. This is just looking at that data in a slightly different way. So the colors here, going from left to right in each column, are showing you the number of women over time in all of these different fields: biology, chemistry, math, physics, And so you see that in general, there's an upward trend, meaning that more women are going into these fields over time. That's a good thing. So that's a sign of progress. But it also shows that this is a percentage here. So biology and maybe chemistry are starting to be towards equal numbers of bachelor's degrees, but physics is still way below. Computer science has actually declined in recent years. So we still have a long ways to go in terms of achieving equality, getting more women to go into these fields. This is showing the same holds true if you look at the number of women who are actually taking those degrees and going into STEM jobs. So this is equal numbers here, 50%, and also looking at the trends over time. You can see again, there's upward trends in general here, and so there's more women. We're getting closer to equality, which signs of progress. Note this is going back to 1960 though, so we would hope there's been a little bit of progress since then. But again, even the biologists here, when you look at the ones who are actually pursuing it as a career, are below 50%, and the engineers are, hovering just a little below 10%. So we have a long ways to go. So what's causing this? And what can we do to change it? So the critical point to remember is that girls' achievements in math and science are shaped by the environment around them. Like, fundamentally, at its core, this is, a very, very well-established truth. And so what is the environment around them? Well, I hate to pick on the Big Bang Theory. I can be an example. I watch the show from time to time too. But it does sort of really play right into the stereotypes of, Penny, who's very nice and popular, and all of her nerd friends who are socially awkward and can barely interact with other human beings, but do perfectly well interacting with their computers. So these stereotypes, in some sense, you can say, oh, well, it's just a TV show, but really, you know, these stereotypes are pervasive in every facet of our lives. And so, you know, we've made progress, but these negative stereotypes about girls' abilities in math and science still persist. So, you know, if you ask somebody if they think that girls can't achieve what boys can in math or science, you know, the vast majority of people are going to say, oh, of course girls can achieve what guys can. You know, the presence of overt bias against women in these fields, it has largely gone away, and that accounts for a lot of the progress that we've made in the last few decades. But it's this unconscious bias that really is the harder thing to get rid of, and that's what's remaining. So it's these negative stereotypes that people hold subconsciously that is what we really need to work on. And by the way, when I talk about people holding negative stereotypes, I'm talking about men and women. There was a study recently where this applies to only women at the professional level, not young girls, but they took two resumes that were identical, fake resumes, and one had a man's name at the top and one had a woman. They gave them to a bunch of different professors, I think, to see who would want to hire them as a postdoc. And there was a strong trend towards professors being more likely to hire the man than the woman, even though the resumes were absolutely identical. And there was no difference in the male professors and the female professors that showed that preference. So everybody, even the women, have these unconscious stereotypes in their heads. We tend to associate science and math with being male pursuits and humanities and arts with being female. And so that's what we need to work to try to overcome, especially for young girls who are just sort of learning about these options and what exists. It's really critical time for them, especially in this sort of preteen, middle school time, to look at the options that exist for careers and decide in their heads what is feasible for them, what's going to make them look cool. These are all things that are very critical at this point in time. So one thing that we know from study after study after study is that these negative stereotypes about girls in math and science directly affect their performance. We can see this as a measurable effect. And so this is a result from a study showing that math test scores, so it's, a reasonably hard math test was given to a sample of men and women at maybe college age, I'm not exactly sure. And before the test was given, the test giver said one of two things to them. Half of the group was told men perform better than women on this test on average. And half of the group was told that statistically there's no difference between men and women's performance on this test. And you can see the results quite clearly, that there's a huge disparity in the performance of the men and women in the case where this stereotype threat, they call it, was given to them beforehand. The women were given the idea that they weren't going to be good enough on this test. Whereas there was no statistical difference between the performance when they were told beforehand that men and women performed equally on the test. And another issue, so this quote from a sociology professor saying that boys do not pursue mathematical activities at a higher rate than girls do because they are better at math. They do so at least partially because they think they are better. This is a confidence issue. So, I mean, this is, again, a measured fact in many studies that a grade that, for an equal grade, the boy and girl would achieve, the boy can say, oh yeah, I'm doing well, I'm really picking this class and I'm, learning things and doing great. Whereas a girl, even if she gets a slightly higher grade, will say, oh no, I'm not doing well enough, this is too hard for me, I might need to drop out. And so again, this is a self-confidence issue that girls are just typically harder on themselves when it comes to performing in these traditionally male-dominated fields. But the good news is that we can turn this around. And like I showed the thing before about how if you either have a stereotype threat before, tell the girls that they aren't expected to do as well, versus telling them they are expected to do as well, you can make a big difference in their performance. So you can use that on the positive side to try to eliminate their unconscious fears ahead of time and make them simply aware of gender stereotypes and their effects. And this has been shown to measurably improve girls' performance in traditionally male-dominated fields like math and science. Girls do better in math and science when they are aware of negative stereotypes around them and are aware of how it influences their performance. And so, some of the ways to overcome this and show them, that these threats are just stereotypes and nothing more, is exposing them to role models in math and science, and teaching them how to recognize them when they pop up. Again, Big Bang Theory would be a great. I hate to pick on it so much, but no, it's a great example to use and talk about okay, what's really going on here with Penny and these boys, and what can we learn from this? Is this really a good example of a woman in science fields, or is this just perpetuating stereotypes that aren't really true? The other thing that has been shown to measurably improve girls' math and science performance is if they believe in the potential for intellectual growth, right? So you can believe that your talents and your strengths are innate and intrinsic to your being, and you had them at birth, and you had gifts, and you're going to use them, or you can believe that you have the potential for growth. And it turns out that math and science skills can be acquired over time, and that you can learn them. It's not just a matter of talent, but girls need to understand and believe internally that this is true. So it's very important to teach girls that intellect is acquired. It's not innate. You have to work hard, praising them for effort along the way as part of the struggle. It's going to be a struggle to learn something hard, and anything that's worth doing is going to be challenging. These are all very important messages for girls to internalize, so that when they encounter something difficult, or when they encounter themselves being the only girl in a class full of boys, they don't just automatically give up. So I think that's probably a good stopping point for now, if that works for you guys. I think, do we have time to do questions now, or should we save them for the end?
Let's save them for the end.
Okay. Yeah, maybe when we come back, we can do, if anybody has questions on this first part, we can do questions, and then we'll go on. So, yeah.
Okay, just a little check-in here. I have it's about 10:10, and I am very controlled today. They have told me that I must be on the dot because your daughters will be finished at 11:20. So we want to be wrapped up, ready for you to meet the girls. So let's say that we take a 20-minute break. We have bathrooms all in this corridor. Girls, Jimmy, can we have some lights? We have girls in the back. They're going to show you, going to an area over here, we call it the gazebo area, and have light refreshments. Bathrooms are all along the corridor. And then, girls, will you make sure that everybody is back by no later than 10:35? Is that all right? 10:35. So you see the girls in the blue shirts in the back. Just follow them. And while you're out, we really want to give good questions to Dr. Blecha when you all come back. Give her some hard ones. We have all your emails, and we'll send it to you online if you prefer to do it that way. Again, we must finish by 11:20. Those are my very serious directions. And at that point, we will go out back or here to the side, and the teachers and the presenters will have your daughters ready for you. And finally, remember that if you have any opportunity to thank Bank of Hawaii, please do so. Now, Dr. Blecha, we're ready.
I thought that before I move on to more of the presentation, I would take a minute to see if anybody has any questions on what I've said so far, or comments, anything at this point. And we'll do questions again at the end too, but really don't hesitate if you have any questions now. Anybody? Okay. And there are floor mics here at the front and the sides. Doing your exercise. Good morning.
The question is more not as how to promote our girls to get into the STEM jobs or interested in that area, but as they grow and they still encounter some of the stereotypes and societal blockades per se, how do we change the rest of society? How do we change our young men's perspective on accepting our daughters' dreams, I guess?
Yeah, I think that's a very critical point, and I'm really glad you made it, is that it's very important that we talk to our girls about these negative stereotypes and how they are just stereotypes. There's no grain of truth to them in terms of innate ability being what determines your success, or there being any innate difference in abilities between genders. But it is just as important that we pass on that message to young boys, because they're the ones that are going to be growing up. And we were talking over break, you made the excellent point that these are the boys that are going to be working alongside these girls, and they're going to be the future of society, and determine whether or not the environment that the girls encounter is one that's welcoming and striving for equality. And so I think it's really important that everybody be aware that our society still is structured in a way that men traditionally are in science and math fields, and traditionally have more leadership positions and are in more of the senior level positions, and women are not. And women are expected to take on a larger share of in terms of family duties and things like that. And so I think if everybody learns from a young age that some of these stereotypes exist, that they can be overcome, then that's only going to help shape the future and give everyone a better chance at succeeding. Is there any other questions?
I have kind of a question statement type thing. You've said a lot of positive and a lot of encouraging for these girls, and that we as parents and society, we should encourage them to follow through with STEM type jobs, education. What about discouraging non-STEM stuff too? I mean, I personally don't think it's not just enough to say, this is good, do it. We need to really discourage the other end too. And there's good points. Because you can say, don't eat this chocolate chip cookie.
Yeah.
But they're going to be like, but that's good. So how do we discourage them?
Right. So the question was about, not only encouraging STEM interests, but do you want to actually actively discourage non-STEM interests? And I would say that my attitude is that you don't necessarily have to discourage girls from pursuing anything that they're passionate about. I think the point that Mrs. White made earlier about the ultimate goal of girls being financially independent is very important. So, if your daughter wants to be a Hollywood actress, it would be good to encourage her to, explore other interests as well, and learn a lot about, the industry of acting and what her actual chances of being an A-list movie star are, things like that. But certainly, non-science fields, as I was telling the girls a little bit, played a huge role in my childhood. I loved music, I still do, and I'm very glad that was a part of my interest in childhood. And maybe it was a little different for me because I kind of always knew that science was like the thing that I probably wanted to do for a career, and that's not the case with all people, that they sort of have this idea in the back of their head from an early age. But I certainly think that it made me a richer individual in the end to have that sort of well-rounded range of interests that I pursued at a young age. So I would say the focus needs to be on helping them develop achievable career goals, and with the ultimate goal of financial independence. And if that's not in a STEM field, not everybody has to work in STEM. But certainly making them aware of things like job opportunities, and you're interested in music, like maybe there's something cool you can do with computers and technology that is in that field. So just helping them to be aware of the actual viable careers that align with their interests is, I would say, a good goal. Anybody else? Yeah.
What would you say was your biggest roadblock that you had to overcome in your course of pursuing something in the STEM field? Was there anything that really kind of almost made you quit pursuing that? And I'm not trying to be negative. I just want to help prepare my daughter so that should she come up against these, how did you overcome it? And what can we anticipate hopefully before she?
Yeah, that's great. So the question was about what was the biggest roadblock that I faced? Did I ever get to a point where I was ready to quit and pursuing my career? I would say that especially in the early years, I was pretty fortunate that I had a lot of strong mentors and peers, and that was incredibly helpful to me. I would say probably the hardest time was in grad school. That's where, there really was a noticeable difference in the number of men versus women in my class to some extent in grad school, but even more when I looked at the professors and the number of them that were women and the senior professors and how even fewer of them were women. It just became more noticeable as I looked sort of down the line in the future. And I was also fortunate that I have very rarely faced overt discrimination. But it's still become, as you learn more about pursuing science as a career and are immersed in it day to day, you sort of become more aware of the subtle things that I was talking about, about people's attitudes about family, work balance for men versus women, people's attitudes about, a woman who, dresses like a woman instead of just wearing men's clothes and try to blend in with the guys type of thing. Those sort of subtle things become more prominent. So no, I would say I was more fortunate than some that I never really was actively discouraged from it. But grad school is very hard. It's a lot of work, and I encountered a lot of my own insecurities. I certainly everyone had told me that I was smart and that I could do things, but there's this little voice in the back of my head saying oh, but they just don't know. You fooled them all for now, but that someday they'll figure you out. And there's actually a term for that. I learned this in grad school. There's actually a term for that. It's called the imposter syndrome, where it's very common. It's more common among women than men, especially women in the science fields. But this idea that you're just an imposter. You got where you are by luck, or by fooling somebody. You tricked them into thinking that you know something you don't, or you're smarter than you really are, and that it's only a matter of time before they find you out. And I'm going to be honest, it's still something that I struggle with. Looking forward, because I deal with very hard problems all the time, and there is no ready answer for them. I'm the one that's trying to figure them out, and so I feel like it's still a process for me to overcome those insecurities. But certainly, talking with other women, my peers, my other women in the field who are experiencing the same things, and older women who have overcome those things and still persevered, even though they face the same, just having someone else say, I face those same insecurities too. It's okay to feel a little bit insecure. That doesn't mean you should quit. It just means that, society is telling you you're not supposed to be doing this. So that was a very long answer, but I hope we sort of gave you an idea of sort of what my mental process is and, trying to overcome all these things. Is there any other questions at this point? So there was one question during break that I didn't get to answer about someone with two 12-year-old daughters who are very interested in science right now, but are right on the cusp of that critical age where what your friends are interested in tends to be a lot more important than what you might be really interested in, and how to maintain that science interest through that critical time. And clearly, there's no magic answer, but I do think that because one's friends are so important to your being at that age, especially having people around you who are doing the same things, like, you know, not being the only one in your friend circle who's in the advanced math class, or not being the only one in your circle who's, you know, learning programming or going to science club or something like that, is really going to be important. So, you know, my core group of friends, you know, a couple of them became engineers, one became a doctor, a couple are doing non-science things, but we all kind of, you know, most of the kids I ran around with were also taking advanced classes of some kind, and were, you know, doing extracurriculars that involved, you know, like math competitions or something like that. A lot of us were in band together too, you know, so we just shared common interests. We kept busy, you know, with all sorts of extracurriculars, so I think that helps too. You know, even if you're not doing science things, just keeping busy with, you know, positive activities that help your development. But really, yeah, having a group of friends that shares common interests and goals, I would say. I mean, role models help too. You know, looking at older role models and learning how, you know, what they did when they were kids, etc. But I really think just because, you know, your friends shape so much of your outlook on life at that age, that's the main thing. So if there's no more questions, I'm going to move on. Right, and tell a little, you know, I just touched on this actually a fair bit throughout that question and answer period, to tell you a little bit more about my story. So as I said, I was interested in space from a young age. I'm told by my parents that Goodnight Moon was actually my favorite book as a toddler. I'm not going to read anything into that, but certainly when I was old enough to, you know, my parents reading to me when I was a kid was a big part of me loving reading in general. I read all sorts of stuff, science, non-science, fiction, non-fiction. But I definitely did devour any books that I could find on space and the solar system throughout my childhood and teenage years. And this is something that my second grade teacher dug up a couple of years ago. Was some things that I had produced, or second or third grade, something like that. One of my first science fiction stories. You know, chapter 5. So yeah, I was really interested in writing actually for most of my childhood and various creative pursuits. And so, you know, it's just to show again that I managed to kind of intertwine them. You know, not just be doing science all the time, but also writing and playing music and stuff. I definitely remember going to see Comet Tail Bach with my parents. Again, going back to the stargazing thing was a big theme in my childhood. Meteor showers too were a big highlight. I dragged my family members out at odd hours more than once to see some meteor showers. The space camp pictures I showed from before, definitely a highlight of the things that I did when I wanted to be an astronaut. And then there's 4-H, which I mentioned briefly again with the girls. And 4-H, I feel like gave me a lot of things in terms of development. It wasn't really science-related stuff that I was doing. So again, sort of, you know, more well-rounded part, I would say, of my childhood experience. But one thing that it did give me that has been really invaluable was public speaking skills from an early age. I was an excruciatingly shy child, like really, really shy. But you know, 4-H was what you did when you were in Kansas. My dad was a big 4-H'er, my grandparents were big 4-H'ers, and part of that was giving these project talks, like, you know, I built this thing in my woodworking class, and I'm going to tell you how I made it, type of thing. And it was just presented to me as such a natural thing that I started doing it when I was like 7 years old. And you know, and I did some public speaking stuff in high school too. And I think that's, you know, been invaluable to me because no matter what you're doing, but definitely in science, it's true that you need to be able to communicate your results to other people. And so developing those language skills, developing those communication skills really is key. And also it's just a self-confidence thing too. You know, it helped me overcome my shyness and helped me feel more confident about myself in general. So as I said, we did lots of projects in 4-H. Woodworking was a big one for me. My dad owns a construction company and builds houses for a living, so this was, I had a very great teacher. But yes, I would do all sorts of things like this, and gardening and photography, that were a lot of fun and gave me a lot of different experiences. And certainly, bucked a lot of gender roles. My dad had me using power tools by the time I was the age of 10. And really, I think that was only because you weren't allowed to use power tools before age until you were 10. That, otherwise, it probably would have been before that. And as I said, music was a big part of my childhood, and I think really helped develop my creative side, and also, just made me a more well-rounded person than if I had just done science all the time. But it also takes a lot of discipline to play an instrument, as any of you know who do or have kids who are taking lessons. And so I think that's an important skill to learn too. As I said, that strong role models were something invaluable to me. Having people that told me, like, yes, you can do this, yes, it's totally normal for you to want to be an astronaut when you grow up. So my mom and dad obviously were the first people that were, very positive towards me and achieving these or pursuing these interests. And I had some excellent teachers as well that were really great about pushing me to, do things outside of the classroom and arranging, extra things for me to do. One of the great resources that was, we utilized was that I was in a college town, and Kent State University was right there. And so I just want to point that out, since you guys are also in a place with a wonderful world-class research university, that this really is an amazing resource to have locally, and something that you should have to consider if your kid has a passion for something in particular. There very well may be an outreach program in the relevant department at the university. So one thing that one of my elementary school teachers did for me and a couple of other kids who were really into science was actually organize a tour of the particle accelerator in the physics department at the university. So I was 9 years old or something, and got to see this private tour of the particle accelerator, and that was really exciting for me. And that's continued to be an important thing for me when I started college. And as I said, this is sort of college and beyond was the age where sort of these gender biases started to play more of a role, because I was just more aware of what the gender shakeout was, and that people were actually doing this as a career. But thankfully, one of the first people I encountered was one of the most positive experiences. My undergrad advisor was this young professor. She actually got to the university to start her position the same year I was a freshman. And so she was looking for undergrads to do research projects. And, I knew that I was interested in science. I had been for a long time. But I was like, well, this little astronaut thing probably isn't what I'm going to do. And, I ended up going into this interdisciplinary major. I was in physics, but also this interdisciplinary program where I took biology, chemistry, geology, various things. It's like, well, I really should, explore this and see if this is really what I want to do with my life. And I feel like, starting to work with Vicki as an undergrad was the thing that really clinched the deal for me. I said, no, this is really the coolest thing for me. This is what I'm really passionate about. And as I said before, when I was answering questions, having inspiring peers is just as important, I would say, and especially in the earlier years, more important perhaps. I've been very fortunate that I've just worked with some of the most amazing women throughout undergrad and grad school, and today I have amazing female colleagues. This is one of my best friends and my roommate for 3 years in grad school, who is going to start as a professor at the University of Arizona in the fall. Currently has a Hubble Fellowship right now. So she's doing amazing things, and was an amazing first person for me to talk to. Whenever I had an issue pop up with gender bias or something like that, I was like, is this what's going on? What do you think about this? And we would talk about it or complain about it as much as we needed to, and get through it together. This is my graduating class at Harvard. There were several women in it, and I just thought that was a nice picture, because it's inspiring to me how we managed to come up with a pretty good gender ratio of those of us who made it to the finish line that year. This picture, these are my undergrad friends that were in physics, in the physics major with me. We were not in sorority. This is actually a play on Schrodinger's equation that, the sorority girls would print their letters onto different items of clothing all the time. So we decided we needed our own. So we made these incredibly nerdy pants that I still have today and wear proudly. So these were some more awesome women who really kept me going. We actually, at one point, took over the entire executive board of the Society of Physics students at my school because we just managed to have more women than men who were seniors in physics that year. So it was a great experience. And then today, these are a couple of women who are also Einstein Fellows. We recently had a symposium, as we do every year, and we all went to dinner. And so these are a couple more inspiring women who are also doing great things in astrophysics and great friends of mine. So I know that all of your girls are a ways off from applying to college. So I'm not going to talk too much about that process, but I just want to say a few words, especially of the things that, my experience and things that I kind of wished I'd known earlier on. I was completely clueless about applying to colleges when I started. My mom went to college. She went to the school that was in her hometown that her dad taught at, so her selection process was very, easy and limited. My dad went to vocational school and then started his business, construction business. So I didn't really have like a prior, experience of the people who were immediately around me. And almost all of my peers were applying exclusively to Kansas State or Kansas University. And so I spent a lot of time researching what college, and this didn't start until my junior year. I started researching various types of colleges, what's a research university versus a liberal arts college, etc., through a variety of resources and trying to learn as much as I could about it. But the most important thing was that I didn't just limit myself to Kansas State and Kansas University because that's what all my peers were doing. I applied to reach schools around the country, and I think that's really important because I think there's a lot of kids who don't apply to the best schools because they just don't realize that it's an option, or maybe just they don't think they'll get in. But if you don't apply, you definitely won't get in. Schools have financial aid, so the application stage is not really when financial considerations should be the dominant thing, I don't think. My parents certainly weren't rich by any means, but I ended up going to a private university for college. And so I think this is definitely the time to keep an open mind, is when the child is starting to think about where to apply and aim high. I took all of the standard exams early enough to repeat if needed. Again, that's a few years out, but only a couple really. But something that is probably more relevant now is that I took all the math classes I could. And I mean, in lots of schools, I feel like it's maybe a requirement to take math every year through college, or through the end of high school. But it is, I think, fundamentally important for definitely any STEM field, but also just basic life skills. I think taking as much math as possible is important. And as I said earlier, I did not take any computer programming. I really wish I had. And I wish that I had looked more into what options were available. Certainly nowadays, the options online are vastly greater than what was available when I was that age. The video I played earlier is from the website code.org. And they have resources on that website where you can go and it's like learn to code in an hour or something they call it. And you can just sit down and learn how to write some basic commands very quickly that will print something to the screen or make something move around. And it's geared towards all ages, and it's incredibly accessible. So there's a lot of tools like that are available now that weren't when I was going through this. So just sort of to build on that, I wanted to close before we take some more questions by just putting out a few more general ideas for encouraging girls' interest in STEM fields. So local resources, as I said, are very powerful. Now, in general, having a university here is an incredibly wonderful resource, as I said. but particularly for astronomy. I've got to talk about that because, you know, I'm an astronomer, and because you guys are in pretty much the best place on Earth for astronomy outreach. Like, seriously, I knew it would be a lot when I started going to the website and looking at this, but yeah, seriously, there's so much going on. This is, there's an annual open house at the Institute for Astronomy just up the road. I looked it up, it's on April 6th this year, coming up soon. There's public talks at the same place at the University of Hawaii. They also have some of various other sites on the other islands that they stream on the web. This is a snapshot from the College of Engineering High School Summer Internship Program. Just as an example of, I mean, this is something geared towards high schoolers who are interested in engineering or the technical fields. So it's not just astronomy. There's, again, like I said, use those resources, look at what, you know, whatever your daughter's interested in, see if the university has anything available. This is the code.org page that I mentioned. There's other sites that are geared specifically towards girls, making coding more accessible to them, connecting them with other girls and women who are coders and trying to develop their interests. Just more astronomy things. It's, again, that's what I do, and I think it's fun. But also just to say that, you know, whatever your daughter is interested in, astronomy or anything else, again, online resources are widely available. This is, maybe you guys have heard of this before, the Study at Home project, where you can, SETI being the search for extraterrestrial intelligence, where we're taking radio data, you know, just using the radio telescopes to just listen in their spare time, and then, you know, analyzing on computers, see if we hear an extraterrestrial signal, and you can use your home laptop to help analyze a little tiny piece of this data, which is, I think, kind of fun. Similarly, this is another example. This is a project called the Galaxy Zoo, where they've taken a huge number of images of galaxies. And one of the things that we've learned is that the human eye is so much better at picking out patterns than most computer programs that we've developed. So you can go online here and actually, like, just immediately start looking at pictures of galaxies and helping astronomers classify them. And then they just aggregate all of the classifications, and they've hundreds and hundreds of scientific research papers have been published on the results of this project. But it's also a lot of fun. If that's something that your daughters are interested in, they can have a lot of fun playing around with this. So that's all I have in terms of material. But I would certainly like to use these last few minutes if we have any more questions, or if there's anything you would like me to talk a little bit more about.
Who is your biggest female role model?
Biggest female role model?
Yeah.
There are a number of female professors in astronomy that I found very inspiring. I think I'm going to have to say, yeah, my undergrad advisor was probably the most influential. And yeah, I just think she's very inspiring and has achieved so much, you know, at a relatively young age, and really was key in encouraging me to, like, stick with it, even when I was, like, you know, not getting results and things like that. She was very. Yeah.
Do you plan to stay in academia?
I would like to stay in academia, yes. So, as I said before, I have a term appointment, and so I have another few years of funding, and in the next few years I'll be applying for permanent positions to be a professor. So, yeah, that's the plan. You know, and there's other backup plans. You know, if I change my mind, you know, there's plenty of other things I could do. But I very much would like to keep doing research and teaching. Good luck. Thank you. Anybody else? Yeah.
Are you privy to or aware of any standards of knowledge that are currently in the process of perhaps being disproved? World is flat, Earth is Pluto is a planet.
Pluto's not a planet.
Yeah. It's a dog in Disney, I know.
So, yes, actually. So, you guys may have heard that there's something called dark matter in the universe. And in fact, most of the matter in the universe is dark matter, 75% of it. Yet we don't know what it is. We can see when we look at galaxies rotating around just the same way that I talked to the girls about seeing that there's a black hole in the center of the galaxy that we can't see by watching the stars orbit around. By looking at the way that all these stars in the galaxy orbit around the galaxy, we can see that there's a lot of mass there that is not visible in light. And so that's how we know the dark matter is there. We can predict very accurately what it should do because we think it only interacts gravitationally with the visible matter. But we only have theories about what it is. So we think it might be these weakly interacting particles that maybe we could see, like if we look really hard, at. So I actually have another friend. I think I showed a picture of her, one of my friends from undergrad, who has spent her entire PhD in a mine in South Dakota. Not her entire PhD, but she's been back and forth there a lot. In a mine in South Dakota. They just published their first paper. Turns out there's no dark matter in South Dakota. Not that we've seen yet. So they published an upper limit, right? And they didn't actually expect to necessarily detect anything. So they go into the mine to shield from other particles that might interact with their detector and make a confused signal. Anyways, I think in the next few years we have the potential to put some very stringent limits on the various theories of what dark matter is, if not detected directly through various signatures. And that would be a complete revolution because it means we actually know what 75% of the stuff in the universe is. And an even bigger question is dark energy, which you may or may not have also heard of. So it turns out that not the matter only makes up a small part of even the dark matter makes up only a small part of the fabric of the universe, and that the stuff that's making the universe is actually accelerating. It's not just expanding; it's accelerating. It's moving apart faster and faster and faster. This was the Nobel Prize in 2011 was for this. The universe is expanding faster and faster, and that's because of dark energy, which is this stuff that we have even less idea what it is. And so that would be the next frontier after that. And that's sort of like the particle theorists, people who work at the Hadron Collider and stuff like that, are working on theories to try to figure out what that is. So we're not going to run out of things to do anytime soon. Yes.
My question kind of stems off of what he was asking. I think it was in the NASA Center in Huntsville. I saw, I think it was like an IMAX film or something like that, called Space Junk.
Uh-huh.
Is it really true as much as they showed out there?
Orbiting Earth?
Yeah, is it really that crazy of piles of just junk in the space?
So I haven't seen the IMAX video, but I know that it is a big problem for satellites, all the space junk. So I don't know how many of you saw the movie Gravity, probably some of you. So they show lots of interactions with space junk in that movie. And one of the reasons that movie isn't realistic, I mean, I think they were aware of this, they just were trying to make the movie more exciting. But one of the reasons that movie isn't realistic is that they deliberately put important satellites and space stations on very different orbits so that they don't interact with each other much. And that's what allows them to, not get blown to smithereens by space junk all the time. But yeah, I think there is a fair bit of stuff, because I don't think back in the early days people realized just how many satellites we would have and how important they would be to our lives. Yeah. Anybody else? Questions about science or motivating girls or anything like that?
Can you comment on the correlation between aptitude in music to STEM fields?
Yeah, absolutely. So it's controversial, I guess, whether there's like a robust, like scientifically quantifiable correlation. I think at the basic level, developing a sense for rhythm, especially in early childhood, can help your quantitative abilities and help your ability to sort of visualize concepts like fractions, for example. And so I think it can definitely help with that. At the end of the day, I think, at least for me, being involved in music as a kid, the most valuable things that I got out of it, in terms of things that helped me in my career, were, learning perseverance, discipline, learning self-confidence, in, performance and so on. And, developing a community as well of people with like-minded interests. And also, I mean, there's something to be said for creativity as an element of the scientific pursuit, right? Yes, a lot of science progress is very incremental and slow. It comes through a lot of hard work. But at the end of the day, you need to be able to step back and look at the big picture and be able to come up with new ideas or look at a problem in a new way and think of something that no one's thought of before. And so I think having a creative mindset is definitely something you learn from music, and that can help you a lot in science or related fields. Yes?
I have another, and this might not pertain anything to any of this specifically. What are you feeling about patterns in math, science, and the other STEM? And I say this because I was talking with my kindergartner's teacher, and we see early on patterns. If you teach your kids square, circle, and they see the pattern in, like you said, the fractions, half to quarter, whatever. So as a well-educated person, do you still see the patterns, like music? She was asking, so do you see it with patterns and different things like that with the STEM? Does that make sense? I don't know if I can ask that well.
So I think I understand your question. You can let me know if I'm wrong, but I think looking for patterns in things is actually a very critical part of quantitative analysis in general and logical thinking. So looking for patterns in data or in my simulations is, I would say, a very critical part of what I do, what we do as scientists. And being able to break down a problem and say, well, maybe if I look at this quantity and this quantity, we'll see a pattern in how they're related, whereas if I plot it some other way, we'll just see noise. So being able to pick out a signal from the noise, I would say is one of the key ways that we were able to make scientific progress. So yeah, does that answer your question?
I think so, yeah. It's just the importance of patterns, as a child, you see it.
Yeah.
You see it on your homework, on your math, on your whatever.
Yeah.
But yeah, so it
Yeah,
is
recognizing
a
patterns.
skill to have, maybe? I don't know how
Yeah,
else to say
yeah.
it.
I think recognizing patterns is a good way to start developing logical thinking skills. I think that's probably a good way to get it. Yeah.
What interested you to go to Cambridge?
So I kind of had this idea that I wanted to do something a little bit different after I graduated from undergrad and before I started into a PhD program. So it's not like I had to get a master's in order to go on to the PhD program, but there was this opportunity to apply for a scholarship. It's actually funded by the Bill Gates Foundation to go study in Cambridge. It's for all different kinds of fields. I think they focus on STEM fields. So I applied for it, and I was applying for grad schools too at the same time, for PhD programs. But I applied for it, and I got the scholarship, and so yeah, I was like, why wouldn't I go live in England for a year? And I get to do more astronomy too while I'm there. So yeah, that was basically the motivation, was just to be able to do something different, live somewhere different.
And that's just a 1 year?
It was a 1 year program. Yeah. So yeah, I guess that's another good point too, is that looking for, asking counselors and looking for scholarship opportunities, but going into college and then leaving college, you know, trying to be aware of those things, because if you're not aware of them, you can't apply for them. So that's another good point. Yeah.
Could you comment on the education system in the U.S., vis-a-vis the European system or block system, where you will have to take math, science, and certain classes to graduate high school before you go to college? And is that giving us a disadvantage because of that?
Yeah, so my understanding of the primary difference between the European system and the US system is that the children specialize very early on in the European system. So you sort of take a test when you're 12, and depending on that test, you go to the top school, or you go to middle school, or you go to the science school, or the music school, or whatever. And that's sort of the track that you're on through high school. So I can't really comment, I guess, with any authority on the effectiveness of that system versus the U.S. system, or what exactly the reasons are that some other countries are overachieving relative to the U.S. on certain metrics of math and science. But I do definitely think that science education in the U.S. Needs a lot of work, to be one. There's been a big emphasis on testing in math and reading, to the exclusion of the arts, certainly, but even to the exclusion of science education. It's sort of shunted to a side thing, especially in the early years. And I guess there's still science classes in high school, but still, the state standardized tests are, the all be all and end all. And I think that's really hurt us a lot in preparing students to actually pursue science, because again, if they don't know about all of these different things, if they don't get adequate training to learn about different scientific fields, then they can't be interested in it if they don't know about it. So I think giving students more science education early and often would definitely improve our outcomes. Yeah.
One last one that was off of the Cambridge. My family, I come from a long line of high school dropouts. So I was the first college graduate, so I grew up not knowing resources and how to find them. Our daughter last year was surrounded by the best group of friends ever who had that light concept of, I want to go into science, or, they really want to make something of themselves. It was a very small group in the class, and she comes home one day and says, Mom, I want to go to Harvard. And I'm thinking, okay, you can do it. And I'm thinking in my mind, yeah, that's happening, How do you build that encouragement when you don't know yourself how to get and strive for that? And when she was discussing it with me, I was like, well, you can do that, you can do that. And she's like, well, the little boy in my class said that we were all done, the 3 or 4 girls that were talking, said we were done, we would never get to that kind of school, we couldn't go to Harvard. And I'm thinking, well, yes you can, but as a person who is at that kind of, how do you encourage them and get them there, pretty much in layman's terms?
Right. Well, first of all, you tell them that little boy didn't know what he was talking about. But no, I think that's a really good point. And like I said, I felt like I was pretty clueless when I was applying to top schools like Harvard and Western and such, trying to figure it all out. My school counselors helped to some degree. So if your school has any resources that, obviously I guess your daughters are a little young now to be thinking about that, but when it gets to be closer to that time, school counselors can be really helpful in telling you what options are out there, what needs to happen to apply, and so I think probably just planning ahead is one of the best things you can do. Just keeping on top of what is it when they get to be in high school, sophomores and juniors, and keeping on top of things like, are they taking the PSATs when they should be, and when do they need to take their other standardized exams? What are the course requirements? Are they taking, the best course load that they can, that they're capable of, and sort of just, keeping it in mind from the beginning of high school, what will help them to, have a strong application. I mean, you don't want to make their entire high school focus about their college application, obviously, but, just looking into it ahead of time so, they don't get to the fall of their senior year and they're, just looking for the first time at what their application requirements are. I think that's probably the best advice that I can give. Ask other people for advice and, prepare more than, a few months before the application time.
You have great questions.
Thank you.
We've enjoyed having you on our campus. The Science Symposium, I told you, was our 20th year, and it's usually at about the same time. It's late February, early March. So we alert you because we have your email addresses. So we keep the database from year to year, but we hope that you'll join us on another year. Dr. Blecha, thank you very much. Have a safe trip home and enjoy your daughters.